So we're going to be having a look at atomic structure today. So looking at GCSE atomic structure. So we had a look at the history of the atom last lesson, and now we're going to have a look at the nuclear model, just to remind you about key features. So we have protons and neutrons, subatomic particles, which are present at the center of the atom in an area called the nucleus. Now going around the nucleus in shells, we have electrons. Okay, so they're going around the nucleus in shells. Now, in terms of these subatomic particles, protons, neutrons, and electrons, there are two key physical properties that we need to remember. So their relative mass and their relative charge. Relative mass is given in atomic mass units. One atomic mass unit is equal to 1.66 times 10 to the power of minus 27 kilograms. A proton correlates to one atomic mass unit, a neutron 1, and an electron 2,000 times smaller than this, 1 over 2,000. The charge of a proton is positive, +1. The charge of a neutron is neutral, 0, and the charge of an electron is -1. In terms of the radius of the atom, we need to remember that the radius of the atom is 1 times 10 to the minus 10 meters, and the radius of the nucleus is smaller than this at 1 times 10 to the power of minus 14 meters. Now, if we look at the atom, just to understand its size, the atom, if we compared it to the size of a football stadium, so an atom was the size of a football stadium, a peanut at the center of that football stadium would represent its nucleus. Now let's have a look at determining the number of protons, neutrons, and electrons in an atom. So let's have a look at an atom of helium. So it has two numbers that are shown here, 4 and 2. So this number 2 represents something known as the atomic number of an element or an atom. And that is unique to an element. It tells us the number of protons that are present in the nucleus of the atom. It also tells us the number of electrons, but most importantly, it's the number of protons. In an exam, it's the number of protons. The mass number at the top, the larger number, shows us the total number of protons and neutrons that are present within the atom. So this number correlates to the mass of the protons and the neutrons together, and also how many there are. So from this we can work out how many protons, neutrons, and electrons are present within the atom. Because of the fact that the atomic number is 2, that means we've got 2 protons present within the atom. The mass number 4 tells us that if we take the mass number from the atomic number, we get the number of neutrons, which is 2, and then the electrons are equivalent to the protons, so they are also equal to 2. So let's have a look at a different atom now. Let's look at an atom of oxygen. This atom has a mass number of 16 and an atomic number of 8. So from this information, let's work out the number of protons, neutrons, and electrons in the atom. The atomic number is 8, so we have 8 protons. 16 take away 8 is 8 for neutrons and 8 for electrons. Let's now have a look at a different atom, an atom of chlorine. 36 for the mass number, 17 for the atomic number. We have 17 protons, 19 neutrons, and 17 electrons. Okay, so now that you've had a look at how to work out protons, neutrons, and electrons of some different atoms, let's try one that you can do on your own. So let's look at potassium with an atomic number of 19 and a mass number of 39. Pause the video now to have a think and then figure out the answers and then replay when you're done. So the number of protons present in potassium are equivalent to the atomic number, so 19. The number of neutrons are 20 and the number of electrons are 19. Okay, so we've come to the end of the video now. Thank you so much for listening and watching the video. I really hope you found it useful. If you did, please share the video, like, comment, and subscribe for more content like this. All the best and see you on the next video.